Hello, here are your notes for Lesson 2.1, Rational Numbers. At any point in time, feel free to pause the video so that you can write down your notes on the paper that I provided for you. Today we're going to learn to write rational numbers in equivalent forms. And the first thing we need to know is, what is a rational number? A rational number is any number that can be written in the form of a fraction. They use the example of n over d for numerator over denominator. Your n and your d must both be integers. And the one thing that is very important, d cannot be a zero. So your denominator can never be zero. The goal of simplifying fractions is to make the numerator and the denominator something we call relatively prime. Relatively prime numbers have no common factors other than 1. And just to put that into terms that you may understand a little more, you are simplifying the fraction down to lowest terms. Make sure that you cannot reduce your fraction anymore. Again, feel free to pause so you can fill in your information. You can often simplify fractions by dividing both the numerator and the denominator by the same non-zero integer. So in the example that you see on your screen, you can simplify the fraction 12/15 to 4/5. And how you can do that is by dividing both the numerator and the denominator by 3. Once you get that, you divide both the numerator and the denominator by 3. Your answer is in simplest form of 4/5. Let's go ahead and practice. Our first fraction that we are going to simplify is 16 over 80. Think to yourself, what number can divide evenly into both 16 and 80? Many of you may start by thinking small, like 2, or maybe you see 4. I see the big numbers. I can see that 8 will divide evenly into both 16 and 80. So that's where I'm going to start. I'm going to divide both the numerator and the denominator by 8. Now when I do that, I get an answer of 2/10. Is my answer in its simplest form? I'm hoping you will say no. And at this point in time, we need to divide both the numerator and the denominator by 2 to get our final answer of 1/5. Example number 2. We have negative 18 over 29. What number can divide evenly into both 18 and 29? In this problem, nothing will divide evenly because 29 is a prime number. The only number that would divide evenly into both 18 and 29 is 1. So our final answer is just going to stay as negative 18 over 29. Moving on. Decimals that terminate or repeat are also rational numbers. Now let's start with what a terminating decimal is. A terminating decimal is any decimal that ends. It has a final end when changing your fraction into a decimal. To write a terminating decimal as a fraction, you must identify the place value of the digit farthest to the right. You want to use that number, your place value, as your denominator. Any number that is to the right of the decimal will be your numerator. Any number that is to the left of your decimal, we are going to write as a whole number. So another way to write negative 3 2/10 is negative 3 2/10. Again, we want to make sure that we simplify our answers to lowest terms. Let's go ahead and change some decimals into fractions. And the first problem we are going to try is 5 37/100. We notice where the last digit to the right is located. The 7 is located in the 100ths place. That's the denominator of our fraction. All numbers that are located to the right of the decimal point are now placed above the 100, and all numbers that are located to the left of the decimal are whole numbers. Can 37/100 be reduced to lowest terms? It cannot. 37 is a prime number. There's our final answer. Moving on to letter B. The last digit is located in the 1,000ths place. There's my denominator. Anything to the right of the decimal point is my numerator. What number will divide evenly into 622 and 1,000? It's a really big number. Let's go ahead and look and see what would go into both. 2 will divide evenly into both the numerator and the denominator. And when you are finished, you end up with 311 over 500. Final answer. Now the last thing we will talk about today is anytime we want to change a fraction to a decimal, you need to divide your numerator by your denominator. Remind me in class tomorrow, and I'll teach you a song to help you remember how to change your fractions into a decimal. We will have to go ahead and divide once we're all finished. Let's practice. Our first fraction is 7/20. The numerator goes inside our division bar. Your denominator goes outside. Let's add a decimal point and a few zeros. Can 20 go into 7? No. Can 20 go into 7D? It sure can. It can go in 3 times. 3 times 20 is 60. 70 minus 60 is 10. Bring down our 0. And 20 goes into 100 5 times. The decimal equivalence for 35/100 or for 7/20 is 35/100. Now let's try the same thing with 15/9. Numerator inside the box, denominator outside the box. let's go ahead and add a decimal point and a few zeros just to be safe. Can 9 go into 1? No. Can 9 go into 15? Yes, it can go in one time. When I subtract, I get 6. Bring down, which is 60. 9 divides into 60 6 times. 6 times 9 is 54. When I subtract, I get 6. I'm going to bring down my 0. Hey, I think I've just seen this before. Here's 60, and here's 60. What's happening here, ladies and gentlemen, is our number is going to repeat. It is going to continue on forever and ever, and it will never end. When this happens, we need to write this number as a decimal and show that the 6 repeats forever and ever. We put a bar, or the technical math term is called a vinculum, over the numbers that repeat. In this problem, only the 6 repeats, so I only have to write it once, and then I put the vinculum over it. I would like for you to try the next 3 questions on your own, and make sure you come to class tomorrow with any questions that you might want to ask me. We will do lots of practice on converting decimals into fractions, reducing fractions to lowest terms, and changing fractions to decimals. Have a good evening.